Hi, so yeah, let's discuss the disaster recovery plan for this fintech system design. It's a very important aspect of any banking platform where data recovery and high availability, high strong consistency of the data is very important. So yeah, for that we need to properly consider the disaster recovery in case of any fintech banking platform. Or in fact, any kind of system disaster recovery is very important. So how we need to do all of this? Let's revise. These are few of the important components of the system design diagram, which we discussed before. First of all is the primary SQL database server, which will be present in one region. Whatever the cloud option we have chosen, like if we are using AWS or Microsoft Azure or GCP, it doesn't depend. Every cloud option has its different regions, and in each region there are different availability zones present. So one region is very far apart from the other, so there are very minimal or in fact no chance that two regions will be impacted at the same time. Yeah, unless the whole world is being destroyed by nuclear weapon or some. Okay, anyways, so what will be our plan? That primary SQL server will be present in one primary region, and then there will be another region, disaster recovery cluster or region, we can say it, and we will keep our backups in those regions as well. So that disaster recovery cluster or region will contain the copies of all of these. That it will contain the copy of the whole primary SQL database server. So the traffic will still be routed to the primary region and not to the disaster recovery region. But the disaster recovery region will contain the backups of all of those main components which have our sensitive data present. Like it will contain the copy of the primary region. It will contain the copy of all of our Redis clusters, all of our Apache Kafka clusters, because our main events are being present in these. Apache Kafka Redis cluster contains our important session stores, our important cache for. So yeah, that will be present. And then also let's discuss about the CDNs, because they are part that CDN becomes the bottleneck. That is a very rare chance for that. And also it is normally being managed by the cloud. Let's say if you are using the Cloudflare or AWS or Microsoft Azure, whatever CDN which is being used, we are serving our static files, static PDFs, JavaScript, CSS through the CDN. And there, it is a very rare chance that CDN goes down. So it will be there will be regular backups also will be taken for CDNs automatically by our cloud provider and not by us. These backups which we are doing also, the configurations will be controlled by us, but obviously the main backup functionality at the infrastructure level will also be done by our cloud provider. So the main thing is we will be doing the regular backup snapshots of our primary SQL database servers, our Redis and our Apache Kafka clusters. And then one thing which we also need to know is that we will not be doing the regular backups of our backend microservices, because these backend microservices are stateless. There is not any sensitive data present. The main feature which these backend microservices are is that they are stateless and that they are idempotent, so that whenever they want, for each request, if that request goes is being failed, then these with the help of that idempotent key, we can automatically retrieve for those requests. So yeah, that these are three main components which we will be doing for our backup as a disaster recovery plan. Okay, regular snapshots, and then we will be deploying our services across availability zones. One thing we discussed here is that we will be using a dedicated region as a disaster recovery cluster region, where we will be using the backups of our main components like database, Kafka, and Redis replicas. And one thing further, that in each region, we know that there are different availability zones present. So we will be deploying our services, which will be handling traffic across these different availability zones. Also, what I'm talking here is that, as you can see here, that we are using multiple squares for each of the backend microservices like auths, accounts, ledger, notifications, and same goes for Apache Kafka cluster, and also same goes for Redis clusters, same goes for the primary and secondary SQL database servers. So in this case, primary SQL database server will be present in one availability zone, and secondary SQL server, which is serving as a backup, will be present in another availability zone. So it will help in properly handling the disaster recovery scenarios. And same goes with all of these backend microservices. One node of the auth service will be present in one AZ, and the other will be present within the other AZ. And our global load balancer, and then the local load balancer. Here I have only used global load balancer, but in the actual scenario of any cloud provider, there are multiple load balancers present. One is the global load balancer, which decides that we need to route the traffic to which region. And then there will be another local load balancer present for each region, which will decide that it needs we need to route the traffic to which node of that region. So that's how it normally goes. So that also makes sense that the global load balancer goes down. That is a very minimal chance for that because it is also being distributed to different availability zones. Okay, so that is another important point here, that we will be deploying services across multiple availability zones. And we have also mentioned before that all backend microservices will be stateless and idempotent. So that's why we will be not using these backend microservices in our disaster recovery cluster, because these services are stateless. There is not any sensitive data these services are containing except the main our code. So these services, whenever we have a disaster recovery situation, based on our global load balancer will route the traffic to our disaster recovery cluster, and these services will be up in a minimal time in that disaster recovery region automatically. These is normally being done by the Kubernetes to up those stateless backend microservices in the disaster recovery cluster. And then it is also the responsibility of global load balancers and then the local load balancers to keep on regularly checking the health of all of those backend microservices. And then the leader election. This is a very important algorithm present. Raft algorithm is being called. So in this algorithm, what is normally happening is that in all of those multiple nodes for each of the backend microservice, one node will be the main, it will be the leader, and all of the other nodes will be the followers. And based on this algorithm, we basically decide that how to properly navigate the traffic to the leader. This implementation of algorithms like Raft algorithms, and then we have some other present also in the market, but the Raft algorithm is mostly famous, and that's what we will be using here. The leader election that is being implemented at the load balancers level. Load balancers basically decide that they need to navigate traffic to the leader, and then leader will communicate with the followers and will keep them up to date. And if global load balancers and load balancers will keep on checking health of all of the leaders, and if any of them fails, then it will automatically navigate traffic to one of the followers based on that election. So that's how it basically normally goes. So yeah, local load, we have already discussed that we will be using global load balancers and then the local load balancers. That now this is the normal flow of any request, any idempotent request. So the user or the client sends the request and DNS, and then global load balancers from the DNS global load balancers, it will be decided, and then global load balancers will navigate traffic to the primary region load balancers, local load balancers specific for that region. And if these load balancers somehow fail or they are down, then global load balancers will navigate traffic to the disaster recovery region load balancer. And then one other aspect of disaster recovery plan is the regular disaster recovery drills for the whole system design. Like it is to intentionally inject some faults, some bugs into the system just to check the resilience and fault tolerance of our system. We can do that intentionally by, for some time, putting our primary database down, or also to make some intentionally put some bugs into our system, keeping our Redis cache down for some time. So we can do that intentionally, and that is a very important aspect to check the resilience of our system. And then these are some of the objectives of our system, standard which are present in the market, RTO and RPO. These are basically recovery time objective and recovery point objective. That, let's say we are taking all of the best steps to make our system resilient, but still there can be a situations present where our system is down for some time. So in that scenarios, the best time is that our system will be recovered and our traffic will be navigated to the disaster recovery cluster. The time standard for that is basically minutes to less than 1 hour. Normally, it should be within minutes. And the data loss. So because in this situation, data loss is near zero, we can say almost to zero. There should be not any data loss present. And that's why we are regularly taking snapshots and moving our data to our disaster recovery cluster. There should not be any data loss. But for related to the time, we can bear some amount of time while we are navigating our traffic properly.